football, baseball, basketball, tennis, and cycling. While these sports are different in style, they each share a key principle of physics. Rotational motion, the motion of a rigid body represented by an angle and radius along a circular path. Rotational motion is measured using three factors: angular displacement, angular velocity, and angular acceleration. Angular displacement is the angle in which an object rotates. Angular velocity is the rate of change in angular displacement over change in time. And angular acceleration is the rate of change in angular velocity over change in time. To describe the angle of a rotating object, we measure the amount of radians within the circumference of a rigid body using the equation radians is equal to degrees times pi over 180. The use of radians is helpful in sports such as cycling when we want to find angular velocity using a given angle and time. Rotational motion is produced when a net torque, the tendency to produce rotation, is applied to an object. Torque depends on the magnitude, direction, and location of an applied force. For example, when a football player is tackled, torque is applied to the player's center of mass, thus producing rotation. This is also observed in sports such as baseball when a ball is struck, and tennis when a ball is served. An object's net torque is equal to angular acceleration times inertia, the tendency to resist change in motion. In fact, larger objects have more inertia than smaller ones. Consider two basketballs, A and B, that are released from the same height at the same time with the same amount of force. Ball A has a smaller mass than ball B. When released, ball A will hit the ground before ball B. This is due to ball A having a lower rotational inertia than ball B. Ball B will have a slower acceleration due to its high rotational inertia amongst a constant force. Now, whether it's riding a bike or hitting a ball, rotational motion is what keeps the planet spinning. And like the world of sports, our Earth's rotational motion allows us to appreciate the science that's all around us.